Let me start recording. Okay. Please give the heading. And I think it is not connected. So please write the heading hysteresis and hysteresis curve. Hysteresis. Whatever you want to say. Okay. So basically what is hysteresis? It is basically a property of what? It is a property of ferromagnetic substances only. Property of ferromagnetic substance. We'll learn more about this particular thing. What exactly is it? So it is a property of ferromagnetic substance, and to understand hysteresis, we need to understand the uh, IH curve, I versus H curve. So what was I and what was H? Guys, do you remember what was I and what was H? I was basically the intensity of magnetization, and basically this was the magnetic, basically magnetizing field. Magnetizing field, right? Intensity. So this was the intensity of magnetization, and this was the intensity of the magnetizing field, right? So what exactly this was, in simpler terms, if I say what is H, H is basically the it is an external factor due to which the magnetic substance is getting magnetized. In simpler words, I'm trying to explain it to you. See, what is H? H is basically it is an external factor due to which, what is happening, which is trying to magnetize a ferromagnetic substance or whatever substance it is. What is I will tell us what I will give. I is not me, na? This intensity of magnetization will give us an idea that on applying this external magnetic field, or basically this on applying this H, how much or to what extent the substance is getting magnetized. So can you understand the difference between them very clearly? In both the cases, both are defined for when, the substance is getting magnetization. We know this particular thing. If both the factors are defined when the substance gets magnetized, right? But can you see over here, H will is basically what? H is the external factor due to which the substance is getting magnetized. And due to this H, how much the substance is getting magnetized, to what extent the substance is getting magnetized, will get an idea from the factor I. Is this clear? So basically, I'll be drawing an I versus H curve. I'll be explaining you the whole curve. Don't worry. So suppose. ज़्यादा बड़ा बन गया. So basically, I'll be drawing an I versus H curve. So can you see I is taken on the y-axis and H is taken on the x-axis. To understand this I versus H curve, let us assume there is a solenoid in which I have kept this polarity which is there, and inside this solenoid I have kept a soft iron core, or basically whatever a ferromagnetic substance is there. If there is a soft iron core, whatever it is. Okay, this is a ferromagnetic substance, or whatever substance you want to get magnetized. Basically we put it inside inside the solenoid. Now can anyone tell me what will happen when you close the switch? When we close the switch, a current, acha, can you see initially when switch is open, can anyone tell me what will happen when the switch is open? The current in the circuit will be zero. Yes or no?
Yes, sir.
Due to which, if there is no current, then this solenoid will not produce any magnetic field. So the B external, or basically the B naught, which we say, is also zero. If B naught is zero, then automatically H becomes zero, right? Because B naught and H are related how? We know this thing, no? B naught is equals to mu naught into H. ये याद है सबको? अरे हाँ या ना?
Yes, sir.
So if
Yes, sir.
current is zero, then B naught is zero, B naught is zero, then H is zero, and if H is not there, do you remember there was a relationship between H and I? The ratio of I by H was equals to the susceptibility, right? So can I write from here, I is basically the susceptibility into H. Can I write it like this? So since I and H is also directly proportional to each other, because this thing is a constant parameter for any material. So if H is zero, then automatically the I is zero. If there is nothing which we can, which will be magnetizing, then the substance will not get magnetized, right? Yes or no? So basically the graph, can you see over here, H is zero and I is zero. So basically the graph will start from this point, which is basically O. Okay. So this whole thing is happening at O point initially when the switch is open. Now what happens? When you close the switch, what happens? Guys, please keep on writing with me, and I'll draw the whole graph in this only, right? So don't think like I'll be drawing different graphs for different points. I'll be drawing the graph over here only. I'll be explaining you different points. Now, if when we close the switch, what happens?
Current starts
The
flowing.
current starts flowing. The current starts flowing. Let's say initially the current is flowing in what direction? Initially the current is flowing in the clockwise direction, right?
Yes, sir.
Let's say initially it is flowing in the clockwise direction. If it is flowing in the clockwise direction, let's say a magnetic field is produced, and whatever is the direction of that magnetic field, the same direction of H will be there, right? So
Yes, sir.
what will be happen initially when the current will start flowing? The solenoid starts producing magnetic field, and due to this magnetic field, will H be present in the space?
Yes, sir.
In one particular direction, whatever direction it is, let's say from left to right. Okay, so let's say initially the magnetization is, the H is present from left to right. Now what will happen to this H? Now we know this particular thing, I is equals to xi times of H. This linear relation follows when the substance is diamagnetic, right? Oh sorry, paramagnetic. I and H, they vary linearly only when the substance is paramagnetic. If it's a diamagnet, if it's a ferromagnetic substance, which we are talking now, then this is not directly proportional. It increases, yes. I and H, is a increasing function, but they are not increasing linearly. Okay, so when H will be present, even I will be present. Please remember, this I is not me, this I is the intensity of magnetization, don't get confused. So even I will be present, right? So what happens if you increase the current? If the current increases, automatically H will also increase, and if H will increase, I will also increase. But please remember, this I will not increase linearly. It will increase for sure, but in ferromagnetic substance, it does not increase linearly. So sir, how does it increase? When we try to plot a graph between them, the graph looks like somewhat like this. Okay, so can you see, initially when you apply H, the material is getting very readily magnetized. Can you see, initially the magnetization which is happening, it's happening very quickly. Can you see, the for a small increase in H, this graph will go up very readily, right? But after a certain point, what will happen, even after increasing H to a certain degree, the I value will become constant. Why will it become constant? I'll tell you the reason. See, when you see a ferromagnetic substance has what? Lots of dipoles in it, right? Initially, all the dipoles are randomly oriented. Yes, guys, please listen carefully. Initially, all the dipoles are randomly oriented. So as soon as you apply an external magnetic field, then those dipoles which are at a very lesser angles, from the magnetic field, they get initially fatapat, they get aligned, right? So initial alignment is very much as compared to the final alignment, right? So initially what happens ki, as you increase the value of H, the value of I increases suddenly. That's why the graph is pointing like this. We are just talking about O to A part only. So initially the graph points like this, and after certain time what happens, the graph becomes like this. So can you see, even after increasing H, the value of I decreases, the value of I increases slowly, right? Earlier it was increasing faster, matlab quickly. Initially value of I was increasing very quickly, but after certain time the increase in the value of I is not so much, and at one particular value of H, I becomes constant. So after this, at this A point, what will happen, guys? At this point, A point, what will happen? The I will become constant. So even after you increase the value of H, even if you increase the value, if you keep on increasing the magnetic field, if you keep on increasing the current, this point will not go further up or down. It will go straight like this. Are you getting my point, guys? Is this clear? So at this point A, the I will become constant. We can write, after this point, if we still keep on increasing H, I will not change. Why I will not change? Because all the dipoles present inside the substance, present inside the substance have been aligned. So till the time the dipoles were getting aligned, the value of I was increasing with increase in H. But once all the dipoles have been arranged, I don't think I will increase or decrease, right? Yes or no? So is point A clear, everyone? The reason also clear? Please keep on writing with me so that you can understand the whole curve. We will discuss two quantities also in this curve only, retentivity and coercivity. Guys, OA part clear, everyone? Is the OA part of the curve clear, which we have drawn over here? Is this part clear? People, is this part clear which we have drawn? Hello.
Yes, sir, it's clear.
Yes, sir.
Yes, sir.
OA part clear हो गया. Now, since the current on increasing the value of H, there was no any there was not any effect on this. Actually, by the way, this A point is basically called as what? This A point is called as saturation point. Saturation point is basically a point where all the dipoles get aligned along the direction of the external magnetic field, so that no increase or decrease in the magnetic moment of the material takes place. So that is basically the saturation point. Now let's try to do one thing. Now let's decrease the current. Now let's decrease the current, keeping the direction same. Yeah? The direction of the current is kept same, but we are decreasing the value of the current. What will happen when I do so? Can anyone tell me what will happen at the time when I do so? The value of H will change, right? The value of H which came over here, it will start decreasing, right? But will it change the direction? Will it go to this hand side? No, right? Yes or no? So basically, what am I doing now? I'm decreasing the value, decreasing the magnitude of current, keeping the direction same. By doing so, what will happen? The magnitude of H will decrease, but direction will remain same. Okay. So now what is happening? The value of current is decreasing. If current is decreasing, then H will decrease, and if H is decreasing, then I will also decrease. Yes or no?
Yes, sir.
So let's say I kept on decreasing till the time we kept on decreasing current. Small I is current, capital I is intensity, है ना? Till the time H becomes 0. So basically we kept on decreasing till the time h became 0. But at this particular time, our assumption was what? This graph will retrace its path back to O, right? Our assumption was this only, the graph will, since I'm increasing, so it goes to A, and then if I keep on decreasing, then it will reach to O, right? But this does not happen. What happens in this case? The graph does not go back to I, it goes to this particular point. Let's name it as B. So basically the graph which was supposed to go back from A to O does not go from A to O, it goes from A to B. I'll tell you the reason also. We observed that the graph does not go back to O, instead it goes to B from it. So what we have assumed, that graph will go back from A to O, but the graph doesn't go from A to O, it goes from A to B. Okay. Now, can you see in this particular diagram over here? Even if you made the at particular point B, can you see there is some I present? Can you see it's on y-axis? So there is x coordinate is 0, but still there is some I, right? What do you mean by this particular thing? At this particular point, guys, please keep on writing this thing. This is your very important thing, as you're as concerned with your school syllabus. So it's theory only, but I'm trying to explain you. So we kept on increasing. ये हो गया. So at point B, even if the value of the magnetizing field H is equals to 0, still the substance has retained certain magnetism. That implies what? Even if the magnetizing field you made it to 0, some dipoles are still in the same direction. That is, even if external field was removed, some dipoles are still aligned.
शिव सर कॉल किया मुझे.
What? Hello?
शिव सर.
नहीं किया sir.
Okay.
So even if external field was removed, some dipoles are still aligned in the same direction. Or we can say, can you see over here? I've used this term retain. Some magnetic field is still retained. Some I is retained, right? And some I is retained. So basically, can you see from here to here? Where is the graph? From here to here, from O to B, this part, this much intensity of magnetization is retained. This property is basically called as retentivity. So basically, what is retentivity? Once you are done till here, then uske baad tell me. Let's start. Guys, whenever you're done till here, just tell me. Done, guys?
Yes, sir.
Okay. So basically, we define something called as retentivity. Retentivity is basically that OB part from O to B. I told you, no? Showed you the diagram as well. This O to B on I axis is basically what? The retentivity. I can define it as, it is a property of a ferromagnetic substance, obviously, to retain its magnetization even when the external magnetic field is removed after okay. So it is property of ferromagnet to retain its magnetization even when the external magnetic field is removed after magnetization. This is, normal definition. You can give the more technical definition. It is that value of I intensity of magnetization which gets retained when the magnetizing field becomes zero after magnetization. So it's up to you, whichever definition you want. That OB part is basically called as what? The retentivity. Okay. Is this clear, guys? Did you understand the graph from O to A and A to B? The first quadrant is done. Now let's come to the second quadrant. Okay. Now, this OB part is, why is it retained? It's because, like, even if you try to decrease the whole magnetic field, but some dipoles are very rigid about rotating. They will say nahi bhai, ab we wanted to get aligned in this direction, you have aligned us in this direction, I don't want to lose my direction in which I'm aligned. So they are like very what do we call it, um, very rigid about this particular thing. They will not move at all. But even everyone can be bribed, right? इनको भी थोड़ी bribe देंगे. So basically now what we start doing, Now let's start increasing the direction, increasing the current, but not in the the same direction, है ना? I'm also doing what? I'm increasing the current in the opposite direction. Sir, why are you moving it in the opposite direction? इसका reason तुमको पता चलेगा थोड़ा. So can you see initially the current which was flowing was in which direction? The current was flowing in a clockwise direction, right? Now I start increasing the current in the opposite direction, or basically here I'll start it in the anti-clockwise direction. If I start increasing the current in the anti-clockwise direction, basically what will happen? What will change over here? When I change the direction of current, what will change? Can anyone predict what will happen when I change the direction of current? What will happen to the solenoid? Will it start producing magnetic field in the opposite direction?
Yeah.
So by doing this, basically what exactly are we doing? We are changing the direction of H. Right? So due to which the direction of H will become opposite. Now your H will increase, but it will increase in the negative direction. So can you see over here in the graph? Now the value of H will increase towards the left side, right? Either increase करेगी. Okay. So now I am increasing the value of H. What will happen? When I increase the value of H, now earlier which with a little bit of magnetization was retained. No? So if I keep on giving this bribe, कि नहीं भाई, I'll keep on increasing in the negative direction. So can you see it reaches a point C? So from B to C, the intensity, even certain rigid dipoles, they start to break, and they start getting aligned in the opposite direction, right? So the direction of H will become opposite. At a certain point C, where the intensity of magnetization becomes 0. So can you see here at this particular instant the substance will get completely demagnetized. Yes or no? Since I made the intensity of magnetization Bicoro at some negative value H, at some negative value of H. The point C is basically that point where intensity becomes. So you can write it in short at point C. When H will be certain negative value, I will become 0. That implies it will completely demagnetize. So can you see one cycle, one half cycle has been completed of magnetization and demagnetization, right? The substance is now exactly where it started, but can you see still certain value of this thing is retained? Can you see O to C part?
So I don't know if it's just me,
Hello?
but your voice is lagging a lot.
My voice is lagging a lot. नेट का दिक्कत है, थोड़ा सा नेट का दिक्कत है, but I'll explain again. At point C, exactly what is happening? Can you see this particular thing at point C? What happens? The graph comes further down. Suppose this is the second quadrant I, and this was the negative H. So this was your point B, and from point B to point C, when it comes like this, at a point C, can you see certain amount of the I becomes 0? The y-axis, can you see the y-axis is 0, but can you see for certain negative value of H, this I has become 0, right? Yes or no? Hello, people, can you hear me?
Yes,
Yes,
sir.
sir.
Okay. So for here, this particular point, we define something new, which is basically called as coercivity. Coercivity is basically from this O to C. Okay, what is coercivity? It is the amount of, or it is the value of magnetizing field intensity applied in the opposite direction of I to demagnetize it completely. Or basically you can say it is the negative H, it is the negative value of H required to make I as. So basically this OC part in the graph is basically what? OC part is basically what? OC part is basically the coercivity part. OB part is basically the retentivity part. Is this clear, guys? OC and OB, retentivity and coercivity, what exactly is it?
Yes, sir.
Okay. And now what happens? Still, you don't stop when the current, this retentivity, this intensity of magnetization becomes zero. Don't stop. So we still keep on increasing the value of H in the negative direction. Now what will happen? Just like the previous case, what was happening? Now this point I and point C and point O are similar. Just like you were applied a magnetic field in this direction, so this thing goes like this from O to A. Similarly, when it reaches over here and you have applied a magnetic field towards the left, then what will happen? Now this point will again increase and it will reach somewhat like this point. So we still keep on increasing the value of H in the negative direction, due to which I will also increase in the negative direction. Basically, what is happening in this case? You keep on increasing H in the negative direction. I will also start increasing in the negative direction. All the dipoles start arranging in the direction of this negative H. So even I become negative, right? Until it becomes a constant at point D. At point D, basically, again, this D point is also saturation point, right? But it is the negative saturation point. D point is also a saturation point, but in the negative direction, right? So after this, if you keep on increasing H, will the value of I change? Will the value of I change? If you keep on increasing this thing, let me copy the diagram again. So at point D, what is happening? Even if you keep on increasing the value of H in the negative direction, the value of I will not change. It will become constant. So D is again a saturation point, which will happen. Now at this particular point, you will change the direction. Now you don't need to write anything, guys. And after this, you can explain on your own. Can you see over here? Now it reached to the point, just like it reached to point A, it's reached to the point D. Now what we'll do? We'll reverse the direction of, oh sorry, you'll keep the direction same. So now keep the direction same of current same and decrease magnitude. So when we keep on decreasing its magnitude, guys, I don't think I need to write the whole thing now, because I guess you can correlate now. So now if I decrease the value of I, again certain amount of magnetization will be retained, but in the opposite direction. This OB and this E are equal. OB and OE are equal. Okay. Hello, people. OB and OE are equal in magnitude, but opposite in direction. Then you will keep on, decreasing the magnetic field. It will reach to a point F. Can you see OC and OF are equal? So can you see the whole thing is getting repeated, but in the opposite direction, and then it will keep on increasing. It will become something like that. Is this clear, guys? So can you see, guys, from F to A also again there is a whole loop. Yes or no? So shall I leave the part D, E, F and FA to you? Guys, can I leave homework D, E, F and FA to you people? Just explain the same way we did for AB, BC and CD. I can write this particular thing. D, E, F and FA are same as AB, BC and CD respectively, just in the opposite direction. So I guess the whole curve is pretty much clear to you. Shall I write CDDE part? It's fine. The same thing is happening, but just in the negative direction happening. Someone may, I'll revise the whole thing for you. Whole thing for you. First, let's say initially it was unmagnetized substance, right? And you start magnetizing it. You started applying a magnetic field, due to which start getting magnetized. So this was the graph from O to A. Then after reaching from O to A, what happens? At point A, there is no further increase in the value of I, even if you increase the value of H. So basically what happens? I becomes constant at this particular point. Point A is basically called as the saturation point. After this, what will happen? You'll start decreasing the value of H, keeping the direction of current same, or keeping the direction of H same. You'll keep on decreasing the magnitude. So what will happen when you started decreasing it? Even the value of I started decreasing. At that particular point B, the value of H becomes 0. But you notice this particular thing, that certain amount of magnetization was retained. OB part is basically called as the retentivity part, and this is the magnetization which got retained. So you try to correct this retention as well by applying a magnetic field in the opposite direction. Now you change the direction of current. When we change the direction of current, H became negative, and now this retented part of the magnetization started getting decreasing slowly, and it becomes 0 at point C. This C part is basically, OC part is basically called as coercivity. Coercivity is basically that value of H, that value of negative magnetizing field strength or magnetizing field intensity, where the intensity of the magnetization becomes 0, or the material becomes completely demagnetized again. At point C, it started decreasing till it reaches a point D. D point is again a saturation point, but it's in the negative direction. At D point, what will happen? The I will become constant again, but in the opposite direction. After this, what will happen? At this particular point, no more increase or decrease in the value of I will take place. So basically, what will you do? You'll start decreasing the value of current. So again, certain retention will be there till point E. Can you see O2 is again a retented magnetization, but in the opposite direction now. If you keep on decreasing it, it will reach point F, and point F2 again point F. Is this clear? This whole loop which is formed, can everyone see the whole loop? Guys, can everyone see this
How
whole?
did they go from F to A?
Yes, what? What? Hello?
Sir, how did it go from F?
How do you go from F to A? See, you keep on increasing the magnetic field. Now, at point E, you have reversed the direction of current, right? To demagnetize it completely, you reverse the direction and current became positive again. So when current became positive again at F point, basically at this positive value of H again, what happened? The material became magnetized again. Sorry, completely. From getting demagnetized, it got magnetized in the opposite direction. So at point F, it will again completely get demagnetized. Point C and F, it will be completely demagnetized. Whatever points which are lying on the x-axis are basically the points where it is completely demagnetized. At O point, it was not magnetized initially. At C point, it became demagnetized after getting magnetized. And at point F, it again got demagnetized after getting magnetized in the opposite direction. Okay. And from point F to A, you keep on increasing that particular thing to again till the time all of the dipole doesn't reach get aligned in the same direction. Till that time, the whole thing gets magnetized again. Okay. So this loop.
So I is increased.
Yes, tell me. Hello.
Sir, from point F, they I increase I and they reach A.
Can you please just put a message in the chat, because your voice is getting repeated, so that's why I'm not able to hear it properly. Anyways, anyone else having any doubt? Hello.
No, sir.
पक्का समझ में आ गया ये चीज? This whole property, this whole thing in which the material behaves such like this in the process of magnetization and demagnetization is basically called as the hysteresis. Hysteresis यही होता है पूरा जो भी phenomena we understood, no? This whole thing is under hysteresis, right? So basically, if someone says what is basically that hysteresis loop, the hysteresis loop is basically what? From point A to B to C to D to E to F. Let me copy and paste the diagram again, please. It will be for your reference only. I'm not able to see the chat. Yeah. Sir, so current is increased and then it goes from here. Yes, current is increased in the positive direction now. है ना? As soon as it reaches E, the current's direction is changed at point E, and what was the point B? The direction of current was changed. I'll write the different points what exactly happening. Okay, sir. Shall I copy one diagram from internet? Much more easy for reference. What did I want? Hysteresis loop. Yes, guys. Are you able to see the hysteresis loop? Can you see the points A, P, C. Achha, they are named as it is E, F, and this was the point which was O, right? So can you see the loop from A to B to C to D to D to E to F to A? ये basically F to A also. This whole loop is basically called as what? The hysteresis loop. Is this clear? Is this clear, guys? At points A and D, these are basically the saturation points. Saturation points are basically where the value of I is getting constant and independent of H, right? Okay. Please remember, A was the saturation point when the dipoles are aligned like this, and D is basically the point where the dipoles are aligned like this. At both these points, can you see the dipoles, direction of dipoles was in different direction? Yes or no? Please remember, the direction of dipoles is same as H. So A and D is pretty much clear to everyone. Now let's talk about point O, F, and C. They are the point where it is complete, where the material is completely demagnetized. Where the material is completely demagnetized. O is basically the point where it was initially unmagnetized. C is basically the point where it got demagnetized after getting magnetized in positive direction. Positive direction is basically this direction, okay? And what is F? F is basically that point where it got demagnetized again, but it got magnetized in the negative direction. Is this point clear, guys? O, C, F clear? Now let's discuss B and E. Okay. B and E were those points where the material retained certain magnetization. B is the point where it retained in positive direction, and E is basically the point where it retained in negative direction. Please remember, OB and OE are is called as what? OB and OE is called as retentivity. The magnitude shall be equal. Although we know this particular thing, OB is retentivity in the positive direction and OE is retentivity in the negative direction. Similarly, OC and OF are called as coercivity. And please remember, OC is in the negative direction and OF is in the positive direction. नहीं, एक सेकंड. हाँ, OC negative है ना? Is OC negative, guys? Yes, it is. So this was all about the graph. Yes or no? I described each and every point to you. I described the whole graph to you. Hello, people.
Yes, sir.
The full cycle of hysteresis कैसे चली? You know, in your NCRT, you might find some applications of hysteresis. It gives you about idea about that and that. So that is all theory. वो थोड़ा एक बार पढ़ लेना. So at point A, it is completely magnetized in one direction. At point C, it will get completely demagnetized. At point C, then it will get completely magnetized again, but in opposite direction at point D, and then it will completely demagnetized, but in opposite direction at point F, and from there it will again get magnetized to, so can you see from A to C to D, F to A? Clear? This is the whole cycle of hysteresis, magnetize and demagnetize. अब मुझे एक बात बताओ कि during this whole cycle, when you will keep on doing work on the dipoles to rotate and align them, are the dipoles so easy to handle? Well, and if I say there is a guy and you are, suppose lying on a bed, he comes and picks you up and puts you in the opposite direction, and then again he comes and then puts you into opposite direction. So will you be easily going like this, back and forth? करते रहोगे क्या? कि will you resist somewhat? You will resist, no?
You'll resist.
So
Yeah.
if you will resist, then what will happen? There will be certain work done, against this resistance, right? And that
yeah.
work done will be lost as what?
Heat.
In the form of heat. Yes. So always remember this particular thing. During this magnetization and demagnetization, during this whole hysteresis loop, certain energy is lost in magnetizing and demagnetizing. In magnetizing and demagnetizing, in hysteresis, then please remember the area of hysteresis loop is directly proportional to the energy lost per unit volume of material in each cycle of magnetization and demagnetization. Please remember, when I say each cycle, cycle means this whole thing. This is a cycle. ऐसा मत सोचना कि sir this is only magnetization and demagnetization. You said no, not from A to C, from A to C to D to F to A. That is the whole full cycle of hysteresis. And in this cycle, whatever energy is lost is basically given by what? The area under the this area. Okay, is directly proportional to this area. So this was it. Acha, by the way, where does this thing come? This losses, this energy loss is called as hysteresis loss. This is basically called as hysteresis loss. And it will come in transformers generally, or wherever soft iron core is used, wherever, for ferromagnetic substances are used. So these losses will also come into play. With this thing, I am done with your chapter magnetism and matter. Okay?
Yes, sir.
Chalo, let me disconnect. Let me leave the meeting and I'll join back again, okay?
Okay, sir.
Or is it okay? If you want, I can give you some question and what's the time left?
We have 17 minutes left.
So let's do some numericals based on magnetic properties. In the next class, I'll start with this thing,
AC current.
AC current. So wait, uh, let me just find some numericals. नहीं, in spite of numericals तो easy रहते हैं यार. इसके मतलब there's normal formula is there. I'll just do one thing. I'll just give you the notes which I have for this chapter. 2 minutes of ना. I'll just send it on the group. Let me find it where exactly. Volume 12. I have not edited these notes, but still you can find some file, export, create PDF. You may find some new things to study in this. So. खाना डन सर. और सब 12th grade. I can stop the recording.